Hello students, today we are going to start our new topic, that is rational number. This is basically the introduction video. So here we are going to study about the definition of the rational number. So here we go. So before moving towards the topic, that is rational number, we should know about whole number. We should know about the natural number and integers too. So we all are aware that whole number are those numbers which are started from 0, 1 and it goes up to infinite. So that are basically the whole number. And the natural number are those numbers which are started from 1 and it goes up to infinity. And integers contains both positive numbers, 0 and negative numbers. Now here we are going to discuss about the rational number. So rational numbers are basically those numbers which can be written in the form of P upon Q, where Q should not be equals to 0. For example, if I am going to say 1 upon 2, here Q is not equals to 0, then we can call it as rational number. But few of you are going to call it as fractions also. So we can say that rational numbers are fractions also. Now rational number can be minus 2 upon 3, it can be negative also. Okay, so that is also your rational number. So from this we got to know that rational number can be positive or it can be negative also. So that is all about the rational number. Now we are moving ahead with the properties of the rational number. So here we goes with the second topic, that is properties of the rational number. So the first property which we are going to discuss over here is the closure property. So the first property will be closure property. And here we are going to discuss the few properties in the 4 operation: addition, subtraction, multiplication and division. So let's check for the addition. So closure properties are those properties in which if the sum of any two rational number is always the rational number, that what closure property states. So here we can say that A upon B plus C upon D is equals to E upon F. Whenever we are adding the rational numbers, whenever we are adding the two rational numbers, then the resultant is also be the rational number. So here we are going to take an example. For example, 1 upon 4 plus 2 upon 3. So after adding this, we should get the rational number. So here I am just checking it. So here I can write like this: 3 by 12 plus 8 by 12. I am just taking the LCM and then I wrote this. So it is equals to 11 by 12. And we know that it is in the form of P upon Q. So that is also a rational number. It shows that addition obeys the closure property. Now let's move to the subtraction. Let us check whether the subtraction obeys closure property or not. So here I am rubbing it. So B1 is for subtraction. Here we are checking for the subtraction. So we can say that A upon B minus C upon D is equals to E upon F. It means whenever we are subtracting the two rational number, the resultant which we get is also be the rational number. So here we are going to take an example: 1 upon 2 minus 3 upon 2. So which is going to be equals to 1 minus 3 upon 2, which is equals to minus 2 upon 2. and here I am cancelling these numbers, and here I can say -1. But here we have to consider in the denominator, whenever we don't have any numbers in the denominator, then we have to consider 1 in the denominators. So again this is in the form of P upon Q. So it shows that subtraction also obeys the closure property. Now let us check for the multiplication. So here I am rubbing it, and let's move to check for the multiplication. So A upon B multiplied by C upon D is equals to E upon F. Now we are going to take an example. So 1 upon 2 multiplied by 3 upon 4. Now after multiplying the two rational number, let us check whether we get the rational number or not. So multiplying the numerator, so 3 1s are 3, multiplying the denominators, here we have 8. So 3 by 8, again it's a rational number. So we can say that multiplication also obeys closure property. Now we are moving for the division now. So let me rub it again and moving towards the division. So A upon B divided by C upon D is equals to E upon F. Let us check whether it is equal or not. So here I am taking an example, that is 1 upon 2 divided by 3 upon 4. Now let's solve it. So 1 upon 2, now this divide is going to be converted into multiplication, and then we have to reciprocal this number. So 4 1s are 4, 3 2s are 6, and we can cancel it more. So here we get 2 by 3, and 2 by 3 is in the form of P upon Q. So again we can say that after dividing the two rational numbers, we get the result also be the rational number. So division also obeys the closure property. So it means that 4 operations, that is addition, subtraction, multiplication and division, all these 4 operations obeys the closure property. Now here we are moving ahead with the next property, that is called commutative property. So let me write over here commutative property. Commutative property. Now let us check for the addition, whether addition obeys the commutative property or not. So here I am checking it for the addition. So commutative property means, let me tell you what does it mean. So whenever we are adding the two, whenever we are addition of the two rational numbers, if we are going to change the order of the rational number, the result should be same. That what commutative property states. So let us understand by the help of example. So 1 by 2 plus 3 by 4. Now let us add it. So 3 plus 1 4, 4 plus 2 is 6. Oh sorry. Now what we need to do, let me just convert this by 2 so that it will be easy for you for calculation. So 3 plus 1 is 4 upon 2, which is going to be equals to 2 upon 1. Now if we are going to change the order, whether we get this number or not, let us check. So here I am writing 3 by 2 at first and 1 by 2 at the end. So let us check those three. So 3 plus 1 is 4, 4 by 2. Here we get 2 by 1. Here also we get 2 by 1, and after changing the order, again we got 2 by 1. So from here we can say that addition obeys commutative property. Now let us check for the subtraction. So here I am only changing it and I am just rubbing these things only. So now we are checking for the subtraction. So let me rub that part only. Now 1 minus 3 is nothing but it is equals to minus 2 upon 2. And we can say that minus 1. Now 3 minus 1 is 2, 2 upon 2 which is equals to 1. And here we can say that minus 1 upon 1 and here it is 1 upon 1. Now here we get minus 1 but here we have 1. So in both the cases whenever we are going to change the order, whenever we are writing the 3 by 2 at the first and 1 by 2 at the end, whenever we are changing the order, that is not going to be equal. So it shows that subtraction does not obey the commutative property. It does not obey as it is not equal. So let us move to the multiplication. So the third one is we are checking for the multiplication. Now a upon b multiplied by c upon t is equals to c upon t multiplied by a upon b. Now by taking this example, let us understand in the better way. 3 upon 2. So what we need to do, we have to multiply the numerators. So 3 1 ja 3, 2 2 ja 4. Now, after changing the order, let us check whether it is equal or not. So, here I change the order. So, 3 1 ja 3, 2 2 ja 4. So, in both the cases, it equal. So, it shows that multiplication obeys the commutative property. Now, let us move and let us check for the division. So, you should also understand that commutative property has only two rational numbers. Here we are only taking the two rational numbers. Whenever the question is going to talk about the two rational number, it shows that there is some chances of the commutative property. Now here we are moving ahead with the division. So a upon b divided by c upon d is equals to c upon d divided by a upon b. Now just take an example. So 1 by 2 divided by 2 by 3. Now let us see whether it is equal or not. So 1 by 2, and here we have to convert this division into multiplication and then reciprocal the given number. So that is equals to 3 by 4. And after changing the order, let us check it is equal or not. So 2 by 3 multiplied by 2 by 1. So it is equals to 4 by 3. So here we got 3 by 4 and after changing the order we got 4 by 3. It shows that division does not obey the commutative property. So that is all about the commutative property. Now let us move towards the associative property. So let us move ahead with the associative property. Now we are going to check associative property for these four operations: addition, subtraction, multiplication and division. So in the associative properties, we require three rational numbers, but in the commutative and closure property, we require only two rational numbers. So let us take a look. C upon D plus E upon F is equals to A upon B plus C upon D plus E upon F. That what associative property states. Now it shows that if I'm going the pair of these two numbers and I'm just leaving this number, then it should be equals to that also. So here I'm taking in the example that is 1 by 2. Now I'm taking C by D as 2 by 2, or we can say that 3 by 2 plus 5 by 2. Now let us solve it first. So firstly we need to solve the bracket part. So 5, 6, 7, 8, 8 by 2, and that is equals to, we know that that is equals to 4. And here we are going to take the LCM, that is going to be equals to 2. So 9 upon 2. So here we get 9 upon 2. Now after changing the order of the bracket, let us check whether we get 9 by 2 or not. So here 1 upon 2 plus, I am just changing the order of the brackets only. Before that I just put the brackets over here. Now I am changing the order. I am putting this 2 number in the brackets now. And what is the remaining? That 5 by 2. So let us go ahead. 3 plus 1, 4. 4 by 2 plus 5 by 2. So we know that that is equals to 2 plus 5 by 2. Again, what will be the LCM of this number? That is 2. So 4 plus 5. So again here we got 9 by 2. So we can see that here also we get 9 by 2 and here also we get 9 by 2. It shows that if you are going to change the order of the bracket, it does not reflect. So it shows that addition obeys the associative property. Similarly, we can solve and check for the subtraction also. Only we need to just put subtraction sign over here. And what you need to do is, you need to just take an example. You just need to take an example like me, whatever I have done in the previous, or you can check that whether it is equal or not. But I have already checked, that's why I am saying that it is not going to be equal. It shows that subtraction does not obey the associative property. So it does not obey. You can take any example to prove this or to understand this. Now here we are moving ahead for the multiplication. So let us take multiplication. So here A upon B multiplied by C upon D multiplied by E upon F, and I am putting the brackets over here, is equals to A upon B multiplied by C upon D is multiplied by E upon F. Correct? Now what you need to do, you need to just take an example of this number, and after taking an example you will get to know that it is going to be equal. It shows that multiplication obeys the associative property. Okay, now we are moving with the division. So here I am only going to change. So the fourth one is division. So let me change the sign over here. Let me change the sign. Okay, if you are going to take an example, then you will get to know that it is not going to be equals to, if you are going to change the order of the bracket, then it is not going to be equals to that. So we can say that as division does not obey the associative property. It does not obey the associative property at all. Now we are moving towards the last property, that is known as the distributive property. So let me rub this. So the last property is the distributive property. That is the fourth property. So what does distributive property means? Distributive property means if I am going to say A and here I am going to say B plus C, that is on the rational number. So what we have studied in the natural numbers, that A into B, or then we have to multiply it by A into C. That we have studied in the property of the natural or whole numbers. So similarly, we need to do the same. So let me consider A upon B. A upon B, and here C upon D plus E upon F. Now what is the distributive property? Now you need to do firstly you need to multiply it by this number, then you need to multiply it by this number. So A upon B into C upon D plus A upon B into E upon F, or simplified manner we can also write like this: AC upon BD plus AE upon BF. That is the distributive property. So what we have noticed, in the associative and the distributive property we require 3 rational numbers, whereas in the closure and commutative property we only require 2 rational numbers to show. So whenever you have 3 rational numbers and the question is asking about which property is applied over here, then you only have to notice that if there are 3 numbers, then you can put associative or you can put distributive. But in the distributive there is a sign of plus, correct? But in the associative property you will not get the sign of plus. If you will get the sign of plus, then you will get the plus sign over here also. But in distributive property it does not happen like this. So that is all about the properties of the rational number. So here we are moving ahead with the additive inverse. So additive inverse means, for example, if I have the number 7 upon 2. If I have the number 7 upon 2, then what I need to do is I just need to change the sign. Then what do you mean by the changing the sign? It means that here it is plus. Then the additive inverse of this number will be minus 7 by 2. Only we require to change the sign. If I have minus 6 by 7, then I just need to change the sign and it is going to be equals to 6 by 7. So that is all about the additive inverse. And additive inverse, if you are going to check this number, the original number and the additive inverse number, you will find that after adding these 2 numbers, we will get 0. We will get 0. So additive inverse gives you always 0. So that is basically about the additive inverse, where you only need to change the sign of the number. Now let us move to the multiplicative identity. So in the multiplicative identity, if I have the number that is 7 upon 2, then in the multiplicative identity you need to reciprocal this number. Then what is the reciprocal of this number? It will be equals to 2 by 7. Similarly, if I have minus 2 by 3, then the multiplicative identity of this number will be 3 upon minus 2. Only you need to just reciprocal this number. No need to change the sign. Only you need to reciprocal the number. That is all about the multiplicative identity. If you are going to see, if you are going to multiply this given numbers, because here we are talking about multiplicative, that's why we are multiplying these 2 numbers, the original number and the multiplicative number, then you will find that you will get 1 only. So multiplicative identity is always equals to 1, whereas the additive inverse is always equals to 0 and multiplicative identity is always equals to 1. Now here we are moving ahead with the absolute value. To understand this, let us take an example. So here if I have 7 by 2, then it is going to be equals to, we need to put it in this, and it is always be the non-negative number. So non-negative number means it is always equals to positive numbers. If we have minus 1 by 2, then again we have to convert this negative into positive only. So that is going to be equals to 1 by 2. So absolute value is always the non-negative numbers. It can never be negative. It cannot be negative. If we have negative, then you have to convert this negative into positive. If we have positive, then no need to change. Then that number is going to be called as absolute value. So let us move ahead. Now rational number on the number line. If we need to represent a rational number on the number line, then how we are going to represent it? So we all know that that is called as number line. So if we have to represent 1 by 2 in the number line. So firstly, you need to divide this number. You need to divide this number like this. So you know that it is going to be equals to 0.5. Correct? It is going to be equals to 0.5. What does it mean? It shows that 0.5 lies between 0 to 1 only. Correct? It is going to be lie in between 0 to 1. So here I am taking it 0 and here I am taking it 1. Now we have to represent 0.5 in the number line. So here I can say that 0.1, 0.2, 0.3, 0.4, 0.5. And that's how we can go up to 10. So here, and we can go up to, or we can write like this also, 1 upon 10, 2 upon 10. We can also write like this, 3 upon 10, 4 upon 10, 5 upon 10, 6 upon 10, 7 upon 10, 8 upon 10. I need to rub this first. So here we have choose the number that is 1 upon 2, and now let me write it again. 1 upon 10, 2 upon 10, 3 upon 10, 4 upon 10, 5 upon 10, 6 upon 10, 7 upon 10, 8 upon 10, 9 upon 10, and then 10 upon 10 is going to be equals to 1. So we required 1 upon 2. So we require 1 upon 2. Let us simplify. 2 1s are 2, 2 5s are 10. That is equals to 1 upon 5. 2 2s are 4, 2 5s are 10. That is equals to 2 by 5. Here 5 1s are 5, 5 2s are 10. So that is equals to 1 by 2. So here we can represent it like this. I hope it is clear with you. Whenever we have the rational number and we have to represent in the number line, firstly you need to divide it like this, and then you will got to know that that particular rational number is lying between which numbers. Here I got to know that it will lie between 0 to 1. So I just wrote, here it is 0.5, so here I just wrote 0.1, 0.2 and so on. But we know that 0.1 is equals to 1 by 10 also. So that's why I wrote 1 by 10, 2 by 10 and up to 9 by 10. And here we have to represent 1 by 2. So I just started cancelling the numbers and I got 1 by 2 over here. So that is the 1 by 2 in the number line. Now, our last topic is rational number between the two rational numbers. Okay, so let's start with this last topic. If we have any two numbers, for example 1 by 2 and 3 by 4, and we need to find the rational numbers between them. Firstly, what we need to do, we need to make the denominators equal. How we are going to take the denominator, how we are going to make the denominators equal? By taking the LCM of the denominators. So the LCM of 2 and 4 is equals to 4. Now we need to multiply that particular number by the LCM. Similarly, we need to multiply that number also by the LCM. So here we have 4 upon 8. Here we have 12 upon. Sorry, I think I have done something wrong. We don't need to multiply it like this. Sorry, I have done wrong. What we need to do, firstly we need to take the LCM. Now we are going to compare this denominator with this LCM. So 2, how many times? 4, it will be 2 only. So here we need to multiply 2 2 ja 4. So here we have to multiply it by 2. Now 4, how many times of 4? 1 time only. So here we require to multiply it by 1 only or divide by 1 only. So 2 1 ja 2, 2 2 ja 4. Now 3 1 ja 3, 4 1 ja 4. So here we have 2 by 4 and 3 by 4. So now we can easily find out the rational number between these numbers. So let me write 2 by 4 and 3 by 4. Then what is the rational number which will come between it? It will be 3. It will be any number, or if we know that there is no number lies between it, we can also make it larger. We can also make, or we can also multiply it with any other number. For example, here we can multiply it by 4 and here we can multiply it by 2. Then we can easily find. If you are facing this problem, you can easily find like this. 4 1 ja 4, 4 2 ja 8, 3 2 ja 6, 4 2 ja 8. Now you can easily find out. Here I am writing 4 by 8. Here I am writing 6 by 8. So what are the rational number which will come between it? That will be 5 by 8. That will be 5 by 8. By increasing this number, you can also find out lots of number between the numbers. Okay, you can also multiply it by 10. You can also multiply it by 6 also. It totally depends upon you. You only have to find the multiplicative of this number only. So that is all about today's class, and that is all about in this video. So thank you so much and have a great day ahead.